Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Zainal Abidin. My matric number is DE210014. So we are from group 4. Our question is question 4, which is Laplace transform. We have this is our team members, which is Evan, Hafizuddin, Shafiq Iskandar, me, myself, Faiz, and then Ashraf. So we are doing question 4, which is Laplace transform. So what is Laplace transform? Laplace transform is a powerful mathematical tools used in engineering and applied mathematics. It simplifies complex functions by converting them from the time domain to the frequency domain. Developed by Pierre Simon Laplace, this transform has become essential in various fields. It converts differential equations into algebraic equations, making them easier to solve. The Laplace transform allows us to analyze functions in terms of different frequencies, uncovering patterns and gaining insights into system behavior. In this presentation, we will cover the basic of the Laplace transform. We will learn how to compute the transform and its inverse, discuss key properties, and see its application in solving differential equation and studying system dynamics. You will also discover practical examples in circuits, control systems, and signal processing, where the Laplace transform is invaluable. By the end, you will understand how the Laplace transform simplifies complex problems, provides a frequency domain perspective, and enhance our understanding of system behavior. And I think that's all for introduction. We will move to the next one.
Hi, my name is Muhammad Ashraf bin Azhar, number matric AE220006. I will explain about manual calculation question 4.
For question 4A1, it is basically a conversion of step function to unit step function. First, we analyze the graph and generate the equation. We use the conversion formula for this equation as shown in the slide. After that, we apply Laplace transforms. E power of negative as over s to the yt, and the final answer is 2 over s minus 3e power of negative 2s over s.
Assalamualaikum, my name is Muhammad Shafiq Iskandar, and today I'm going to present about MATLAB coding question 4A1. In question 4A1, the Laplace transform of the function yt equals to g1 plus g2 minus g1. Every side t minus a is calculated and displayed. The function yt represents a step function with a constant value of g1 before time t equals to a, and a linear change from g1 to g2 after time t equals to a. The Laplace transform of yt is found to be 2 divided by s time s plus 2 plus 3 exponent negative 2s. This result demonstrates the transformation of a time domain function into the Laplace domain. By using the Laplace transform, we can analyze and manipulate function in a more convenient algebraic form.
For question 4A2, we need to find out the reverse Laplace transform of fs equal to s squared plus 5 over s times s squared plus 10. The quadratic factors can be decomposed as fs equal to a over s plus bs plus c over s squared plus 10. Compare the numerators at both hand sides and then compare the coefficient. After that, we sub the values of a, b, and c yield as shown in the slide. Then, inverse Laplace transform can be obtained.
So, for the question 4A2, the given MATLAB could calculate the inverse Laplace transform of the function fs equal to cos sqrt times 10 s divided by 2 plus 1 divided by 2. Using the symbolic variables, the code defines the function fs as 5 to the power of 2 plus 5 divided by s times s power of 2 plus 10. Then it applies the Laplace function to calculate the inverse Laplace transform of fs, which is assigned to the variable fs. The resulting inverse Laplace transform of fs is found to be cos sq rt 10 s divided by 2 plus 1 divided by 2. This MATLAB code showcase the simplicity and efficiency of using computational tools to compute inverse Laplace transform.
Question 4b is the application of Laplace transforms in RLC circuit. The model circuit is given in the question. First, we convert the step function of et to unit step function. Then we substitute the values of R, L, and C into the equation and apply the Laplace transform. After that, we sub the initial condition, which is I0 equal to 0. Next, we solve for Is for both hand sides. Lastly, we do the inverse Laplace transforms and get the final answer as shown in the slide.
Hello, my name is Izwan Osbert Anamikal Jodi. So I will present the coding question for B. As you see, this is the coding for the question for B. So question for B, given that RLC circuit model S L di in the blanket T divided by dt plus I in the blanket T R plus 1 divided by C I and T open blanket I in the blanket X, then close the blanket dx equal to 1 minus 1 times heavy side in the blanket T minus 10. Then L equal to 1 Henry, comma, R equal to 0.4 ohm, then comma, C equal to at F. It's at Farad. Then next SYMS Y in the blanket U STL I P replace I in the blanket T in term of Y in the blanket U. Differentiate Y in the blanket U with respect to U. dy equal to diff in the blanket Y, comma U, then semicolon. Define the differential equation. L open blanket di divide dt close blanket plus R time I plus open blanket 1 divide C close blanket times integral of I dt equal 1 minus 1 times heavy side in open blanket T minus 10 close blanket EQN equal 1 time dy in blanket T plus 0.4 times Y in the blanket T plus 0.125 times INT open blanket Y, comma U, comma 0, comma T, comma, then close blanket, then equal 1 minus 1 times heavy side open blanket t minus 10 close bracket semicolon. Then apply Laplace transform I1 equal Laplace in the blanket u eqn comma t comma s and semicolon. Then substituting initial condition I equal to subs, then open blanket I1 comma y in blanket 0 comma 0 close blanket semicolon. Then simplify the equation. Is equal to simplify open bracket I comma steps comma 10 close blanket semicolon. So that is the coding for the question for B. Then this is the answer. So Laplace y Laplace open blanket y in the blanket t comma s close blanket equal exp open blanket minus 10s close blanket, then open again blanket exp open again blanket 10s close blanket minus 1 close again the blanket 40 divided by 2. So 40 s plus 16 s plus 5. Then the current I in the blanket t equal to y in the blanket t equal sqrt in the blanket 2 sqrt in the blanket 17 sin open big blanket, then sqrt in blanket 2 sqrt in blanket 17 t divided by 20 close the big blanket exp, then open again big blanket t divided by 5, then close again big blanket, and 10 divided by 17, and then minus sqrt in the blanket 2 sqrt in the blanket 17 heavy side t minus 10 is in the blanket, then sin, then open the blanket big blanket sqrt in the blanket 2, then sqrt in the blanket 17, then in the blanket t minus 10, then divide by 20, then close the blanket, then exp, then open the big blanket 2 t divided by 5, then close the big blanket, then 10 divided by 17. So that is the answer for the coding. So I will pass the next presenter. Thank you.
Hello, my name is Hafizuddin and I will continue for the last part, which is conclusion. So, the Laplace transformation is a mathematical technique that simplifies a complex equation by converting them into a different form. It helps us analyze systems by looking at their behavior in terms of frequency instead of time. This approach has several benefits, including easier calculation, a convenient way to study system behavior, and quantity time and frequency domains. With the Laplace transform, we can solve difficult equations more easily. We can also use software tools like MATLAB to double-check our calculation and ensure they are accurate. By analyzing systems in the frequency domain, we gain a better understanding of how they work. This knowledge is useful fields such as control system, circuit, and signal processing. In summary, the Laplace transformation simplifies equations, allow us to study systems conveniently, and connect the time and frequency domains. It is a valuable tool in various fields, making complex analysis more manageable and enabling us to make better informed choices. So, that's all from us. Thank you.